I'm going to ask each one of them. Miserable, I believe, no? What is wrong with the class? मिला नहीं है तो? Sit down, all of you, please. Yes, sir. Shall I openly ask you now how much you got? How much was it about? 15. Anybody who's got more than 12? Yes. How much? 12. 30. Between 10, about 10? You got 30. 10, 10 to 12. How much? 11. One chapter. We did not bother to read. What's wrong with you children? It's an easy lesson. And the more you study, it becomes easier for you. It's going to take a long time for you to revise the whole area. Whether you have it in your school or not, ultimately, this, what did I tell you? Long-term memory. I'm always emphasizing on that. Whatever you need now, it is going to help you for your board examination. We are not looking at the next few months. Your preparations should start from day one. That is it. Or you come back. Not here, definitely. You sit there. And don't disturb anybody there. Now, all those of you who have not done well, look at your question paper, learn all those answers, go through the whole thing again. Physics paper, everybody has given or somebody has not given yet? Not yet. You're not seeing the question paper, right? We'll get another question paper.
I have a doubt in chapter that people on it, that's why I was asking him.
I'll come back to that. Just remind me the last 5 minutes, I'll come back to that. Okay, now come on now. Did you understand? Everyone, have you followed? Go through that lesson on light again and brush up whatever you have done. Such an easy lesson. How many sums, how many times I've done it? All diagrams I put up on the board. Really disappointing. What have we finished? Which lesson are we doing first of all? And at least you remember that. What does part 1 tell us? I said there are 2 parts to this lesson. Part 1 में क्या है? Ohm's law, okay, potential difference, resistance, unit charge, all the formulas are here. The second part में क्या कर रहे हैं? We are basically talking about heating effect of, yes. Okay. Are you calling or is it? Yeah, like you can switch it. So what was Joule's law? Yeah. So first part of it, we just want to quickly remember what is the heating effect. Whenever you have a conducting wire and you are passing current, what happens is it depends upon the condition of the wire. If there is low resistance, that means the flow of charges is taking place easily and it does not get heated up. But if you want to use this as a heating element, for example in an iron or a toaster, Okay, when you want this to become red hot, obviously this should have a higher resistance. Okay, and that produces the heating effect on electric current. Now there are three formulas. Remember, H is equal to, come on, tell me. VID. I square. Those of you who don't know, look at your books and tell me, come on. I've already given you the three formulas I have given you. Yes, H is equal to V I T. H is also equal to V square T upon R. Okay, so this is the heating effect. So depending upon the information, whatever is given to us, we can find out.
Ma'am, is the whole thing upon R or is it just
We have seen last time how we have substituted I using Ohm's law, and that is how we are getting this. Now we have also seen what is power. Okay, what is it? Power is nothing but it is work done upon time. So that is your P. Correct? When you multiply, you get it as work is equal to P into time. Okay, what is this work done? If you want something to work, you have to supply energy. So instead of writing work, I can also use this work energy. How will you remember this? I told you a simple method to do. What did I tell you? How will you remember? In your PT exercises, PT in the exercises in your school, you will be losing out energy. Right? So that is how you can remember. Okay. So once again, if we have got P which is equal to work upon time, this is nothing but the work done. Alright. Can we do the same thing? I square RT upon T. Why? Because it is work upon time. What is this? This is nothing but heat energy. So it is heat energy is nothing but work upon time. So this is upon time. So how much did we get? We got this as I square R. Okay. From this, what do we get? It is VIT upon T. So what gets cancelled out? What is remaining? VI. What are we finding out here? Power. So P is equal to. So P is equal to. Here again for the third one, we have got V square T upon R divided by T, which is equal to V square upon R. So these are the three formulas for finding out power. Is that okay? Using the same thing. What are we using? We are using Joule's law. Using Joule's law, each one of them divided by T is going to give you power. Is that okay? Right. Power is equal to, and this is the one that we usually use. We need to add. Okay. If you don't remember this, we can definitely go back to our Ohm's law. What does our Ohm's law tell us? E is equal to IR. Okay, we can substitute here. We can substitute here. You can understand. Correct? I'm on page number 190. Okay. I've already given you an introduction to the practical applications of the heating effect of electric current. So we have seen, I was telling you about the electric bulb which has got a filament of tungsten. Okay. Why do we prefer to use tungsten? Because this filament has to get heated up and it should not melt. Right? So there are two things that you should remember. First is this tungsten which has got a very, very high melting point. Okay, or you're still right? So we have to see that this filament doesn't get oxidized. Okay? If this bulb is filled with air, air contains oxygen. At very high temperatures, this can get oxidized. Understanding what I am saying? Okay. So instead of air, we are usually going to fill it up with an inert atmosphere. Inert necessarily need not mean it is an inert gas. It can also be nitrogen, which hardly exists. Okay, or even an argon, xenon, whatever it is. That is one. Second thing, I've also told you what type of filament. It is a tungsten filament. If you want more resistance, what do? The length has to be increased. So you will see that the filament is very fine. It is very fine because the diameter is very small and other points are carefully increased. Yes. Yes. Okay. So it is highly coiled. Why is it coiled? Obviously because we are increasing the length. Is that okay? Did you understand? Okay. So this is how we are going to make use of the heating effect of current. Now, we are on page 190. Look at the second paragraph there. Electric heating is also used to produce light. Okay. Filament must retain as much as heat generated. It gets very hot and it emits light. It is an incandescent light. What is it? It is incandescent bulb. Okay. A strong metal, high melting point such as tungsten. What is the melting point? 380. Okay, so see this will resist that high temperature and it will definitely not melt. It is used for making bulb filament. So whenever we are asking you something about why tungsten is used, first and most important thing is because it has a high melting point. Underline that 3380 degrees Celsius. Filament should be thermally isolated. Thermally isolated. Do you understand the meaning of that? Yeah, obviously it should not get oxidized. So therefore, we're using insulating support. It is actually filled with a chemically inactive nitrogen. Chemically inactive nitrogen and argon to prolong the life of a filament. Okay, most of the power appears as heat, but a small part of it, of course, is converted into life energy. Put a Q for that paragraph. Put a Q. Question can be asked. Okay, so we are on this paragraph, on the second paragraph here. Now, next one. Another common application of Joule's law is the fuse. So I'm sure all of you have heard something about, okay, in our common language we said fuse jal gaya, right? What is that? What is happening? So basically, when electricity is supplied to our homes, it passes through what is known as the fuse. And it's only then it is sent to our homes or whatever appliances. Okay. So what happens if there is a surge of current? What if there is an excessive amount of current? Then what will happen is many of the appliances that we have in our home, maybe it is a computer or TV, that will get damaged. Okay, sometimes it can also be a short circuit, it can lead to fire. So in order to prevent it, this is nothing but a safety device. Okay, it is a safety device. So basically what happens, we have a fuse which is something like this. All of you look here, I'll just give you an idea. Now which is made up of porcelain. Most of the pieces is made of porcelain. And here we have got a very thin wire. Okay, it is made up of alloy or it is also made up of a metal. It has got a very low melting point. What is your low melting point? For tungsten, क्या होगा? High melting point. For fuse wire, it is a very low melting point. So what happens basically? Look here, when the current is passing from outside, it has to pass through the fuse wire and only then come to your computer or whatever device. If there's an excessive amount of current, if there is a surge in the current, then what happens is because it has got a very low melting point, it gets heated up. Because it's getting heated up, ये melt हो जाएगा, है ना? It will melt, and there won't be any current, and your device will not get spoiled. And you all follow what is happening. Yeah, I'll show you the diagram also because the diagram is not given. I said, okay, let me just show you this. Yes. See, you get it. See that thin wire here, can you see that thin wire? That's your fuse wire. So that's basically your casing. The whole thing is a casing like that. So there's one above the other. Did you follow what it is? And the inside part of it is your fuse wire. You can see the fuse wire. So when the current is passing, it passes through the fuse wire and then it comes into your house. But suppose there's an excessive amount of current, this fuse wire will melt and there won't be any current. So therefore your appliances are going to be protected. Have you followed? So sometimes there's a built-in fuse depending upon the appliances. So for the computers or for the fridge or whatever it is, there's a built-in fuse. But also depends upon the amount of the current that it is going to draw. It may be for 1 ampere or 5 amperes or 2 amperes or whatever it is. Look at that last paragraph on the page. Once the fuse melts, obviously there won't be any current, then we know that the appliance is not running. You take it out, then we know that the fuse wire has melted. We have to replace the wire. Okay? But nowadays what happens is this is a very old system. We are using it only because to explain our tools. Have you heard of circuit breakers? Yes. Most of our houses we are very familiar with this. Okay, so these are what are known as circuit breaker. It is breaking the circuit. One advantage of this is that you can definitely use it once you find that it has tripped. Okay, that thing moves up, and then afterwards you set the appliance correctly, and then of course you can use it back. For a fuse wire, you have to take it out, replace the wire again. The electrician will do it, and that is how you can replace it. Have you seen it? Okay, sometimes there are micro circuit breakers. It's for very fine currents. Many of the electronic appliances, they need only a very small amount of current. So we don't want too much of current. Come on, look at the last paragraph, another common appliance of the joules heating is the fuse, which is used in electric current. Yeah. It protects the circuit. I want you to underline that. It protects circuit and appliances. So what is it? It's a safety device. By stopping the flow of any unduly high electric current. Okay? So whenever we have got a high electric current, and it is not needed, it is a protective device, it's a safety device, and it stops the excessive flow of current. Okay? The fuse is placed in series. Underline that. It's not placed in parallel. It is always placed in series because the current has to pass through the fuse. Okay? It consists of a piece of wire which is made up of a metal or an alloy of appropriate melting point. Example, aluminium, copper, iron, lead, etc. If a current larger than the specified value flows, the temperature increases. So what is happening to this wire? Temperature is increasing, and because the melting point is low, obviously it begins to melt. Okay? But the fuse wire is usually encased in a cartridge. Do you understand what is encased? See how it is present in it. This is a cartridge which is usually made up of porcelain. The fuse wire is present inside. It is encased inside the cartridge. Did you understand? Okay. Okay. Fuses which are used for domestic purposes, they are all rated. What is the rating? 1 ampere, 2 ampere, 5 ampere, whatever. For an electric iron, which is consuming 1 kW. What is that? Yes, 1 kW. Okay, for example, iron. We want the iron to get heated up. So that's the power which is going to be utilized. Okay, and it is operated at how much? 220 volts. So that is the 220 voltage which is usually given to us. Okay, then that is 4.54 ampere will flow in the current, and in this case 5 amp current fuse must be used. What is the information which is given to us? Power. This is W is given. So what are we talking about? This is our power. Correct? And then you have got your 220 volt. Can you find out what is the current here? V. Can you find out I? Which formula will you use? Correct? Okay. So P is equal to V into I. I can find out I, which is equal to P divided by V. Power is how much in watts?
1000.
1000 watt. V is your 220 volts.
4.5.
How much is that? Do that. 50 by 11. 50 by 11 is how much?
4.5.
Yes. 4.2. Okay, 4.5. What is that? Unit will be what?
Ampere.
Ampere, because we are finding out the current by whatever. Okay, so much of current is required. So what is the fuse that is required there? Therefore, you must use a fuse which is slightly above it. So your fuse has to be 5 amps. Do you understand? You all understand now? The last sentence there. In this case, a 5 amp fuse must be used.
What if we use
The one, suppose you are using a 3 amp fuse or you are using a 2 amp. That won't be able to prevent.
what if we use the same current, same ampere?
No, you have got these values. 3, 5. So if it is even 3.5 or 3.7, you have to use something that's slightly above it.
So now if we use a 4.5 ampere,
Use nothing that's used wire. Those are all ratings. That's why I mean, what is the rating that you get?
so now if it's 3.5, you use a 5 ampere,
Yes.
and 3.1 you still use 5.
Yeah, you can use this. If it is 3.1 or something, then you can use it. Got it? All of you okay? Did you understand? Okay, so these are the things that you might have and you might be using at home, but it is not of this. See the last paragraph there, electric power. I've already given you the 3 formulas. How did we get all these 3 formulas? By using what? Joule's law, heating. Okay? Because P is equal to power is work upon time. We have just done work upon time and I've got 3 formulas. Is that okay? Right? Have you written it down somewhere? Okay, right. So look at the first 2-3 lines there. P is equal to VI. Put a tick mark there. Those 3 formulas are already given. P is equal to I square R and P is equal to V square R. Even if you forget, no problem. Always go back to Ohm's law. Substitute I, substitute R, you will get whatever is required. Okay. What is the unit of power? Capital W. Okay. It's the power consumed by a device that carries 1 amp current when operated at a potential difference of 1 volt. Okay. Because we said P is equal to V into I. This formula, P is equal to V into I. What is the voltage here? 1 volt. This is 1 volt. Current is 1 amp. Okay. So therefore, your power will be as 1 volt.
So what is equal to voltage ampere?
Yeah. P is equal to V into I. I know what is my voltage. I know what is the current which is drawn. I can find out what is the power. Isn't it? Come on, all of you write it down in your notebook. SI unit of power is what? Sometimes they may ask you for definition. Please write it in your notebook. Okay. It is the power consumed by a device. Yeah, definitely. Now it is a definition for what? It is the power consumed by a device. Here it's there in your textbook. Okay, that carries 1 amp current. Right there. Alright. That carries 1 amp current when operated at a potential difference of 1 V. What is that 1 V? Volt. So this is 1 watt, which is equal to 1 volt times 1 ampere. not WH. Watt. Okay, look at this. Boys and girls, look at this. It is not 4, huh? It is not Roman 4. Some of you will think it is 5. No. What is this?
1.
This is 1. V is here. V, volt. Okay, it's not 5, it's not Roman 5. What is A?
Yeah.
Very good. Sure. Okay. In most of the houses, when we are talking about watt, that's obviously very, very small. Yeah, because many times I've come across students thinking that that is 1, 4, 5. What are they thinking? Right. So this watt is a very small unit, right? For example, bulb, you may have 100 watts. So we want a bigger unit, which happens to be a kilowatt. Okay. How much is a kilowatt? We have got 1000 watts is equal to 1 kilowatt. Okay. And moreover, another thing that you should remember is whenever we are consuming it, we are not consuming only for seconds. Okay. So we are using the fan for so many hours. All our appliances are obviously going to be used in hours. So it's a bigger unit. So basically, once again, we come back to P is equal to work upon time, or work is equal to P into T, right? Your power is going to be given in kilowatt, and your time is going to be given in hours. So what is it going to be? It is a kilowatt hour. Okay, so your power is going to be always given in kilowatt hour, and this is equal to 1 unit of your electricity. Have you bothered to see your electricity bill? Your bill are there. Okay. So depending upon, okay, now summers we are using more of AC and all that. The number of units will keep on increasing, right? So if the number of units are increasing, obviously we have to pay more. Okay. So all of us have understood about this unit. So if you look at the units, it's not the same for all the months. Okay, from Jan, Feb, March, May, June, yes, April, yes, high consumption. Once again, if you come to maybe November, December, units are not the same. Right? Sometimes you may have even 700, 780 units. Sometimes it may be just about 400. Sometimes it may be less depending upon the usage of your appliances. These are given in units. How much is 1 unit?
Kilowatt.
Is kilowatt per hour. That is telling you how much of energy is consumed. So we are not per hour, no. Not per hour, it is into. If you say per hour, it is divided by hour. Is it divided by hour? No, it is kilowatt hour. Have you all found out what is that? Okay, so don't make that mistake. So then depending upon whatever the electricity board is charging us, okay, they may say it is 4 rupees 50 paise per unit. Suppose they say it is so much per unit. You know what is your consumption, that times your money will be the answer. Got it? Yeah, we'll write. Come on, write down. Okay. Next in your notebook, write down. Larger unit for power is kilowatt. Larger unit of power is kilowatt. Write down this. 1000 watt is equal to 1 kilowatt. Okay. Write out the definition. Commercial unit of electric energy. Commercial unit of electric energy is kilowatt hour. So that's your kilowatt hour, which is equal to 1 unit. Write it out. Okay. Now, if I have given you as a kilowatt hour, 1 kilowatt hour, how do we change it into joule? How much is 1 kilowatt? It is 1000 watts. Convert hours into seconds. So 60 into 60. So that becomes 36, followed by 1, 2, 3, 4, 5, 10 raised to the power of 5. Okay, this is watt and that is second. So that is watt second. Or we can shift a decimal and also write it as 3.6 10 raised to the power of 6.
But if we write 36 into 10 it's fine, right?
Get it? That's fine. It makes the same. Both of them are same, but only thing is be careful of the.
So, ma'am, this is
That's given in joule. Come, next question. Come on, write down.
how can I write?
All of you should write. Next question. Convert 1. Convert 1 kilo watt hour into joule. 1 kilowatt hour converted into joule. So what did we get here? This is watt second. Okay. So your watt second is nothing but joule. So 3.6 into 10 raised to the power of 6 joule. Okay. Put a tick mark here, everyone. Put a Q there. Definitely will be asked. Okay. Either in your objective or for something or the other. This is one of the very important aspects which we must remember. Now let us see. Got it? Got it?
Ma'am, I was asking why they put like the 3.6 and 3.
We have shifted 1 decimal point. That's it. Okay, now there's a small example here that is easy. 11.12 is pretty easy. Bulb is connected to a 220 volt generator. Current is there. What is the power? P is equal to P into I. That is easy. Okay, let's see 11.13. Let's see 11.13. Yeah. Let's see what is given there. Electric refrigerator is rated at 400 W. See, they're not using the word power at all. But how can you make out it as power? Watt. Yes. Always look at the unit. The moment you look at the unit, we know that it is power. Correct? See, in the sentence they have given us electric refrigerator rated 400 watts. So if you only watt it is actually hour. Okay. Operates 8 hours per day. So time. Obviously they're talking about time. 8 hours per day. Okay. What is the cost of energy? So we have to find cost of energy. To operate for 30 days. They have given also 30 days. Okay. And they have given the rate also, which is 3 rupees per kilowatt hour.
Ma'am, so do we have to cut the hours into seconds?
Only for joules. Because what did I say? 1 unit is kilowatt hour. Here you don't have to convert it. Now let's see here. What is the information which is given now? Time. Okay. How many hours totally are we using? For one day, we are using 8 hours. So how many days? They are asking us to find out for 30 days. Correct? So that's going to be so many hours. This comes later. That comes much later. Now what do we have to find out? Cost of energy. Okay, we have to find out energy. What is the formula? Energy.
Work done.
Hmm?
That is power.
Our P is equal to what?
Into I.
P is equal to
T or PT.
or W is equal to P into T. What is W?
Work.
That's nothing but energy. Right? So what do we have to find out? Energy. First we have to find out the energy. That means you have to convert power. Okay. Not in watts, but you have to convert it into kilowatt. Commercial energy. Unit क्या होगा? Commercial. It is kilowatt. And time will be in hours. समझा ना? Did you understand? We are going to use this formula. Come on, write down. Your formula will be that. Okay. Power is 400 watts. I have to convert it into kilowatts. So I just write it as by 1000. That has now become kilowatt. Time. How much is the time?
240 hours.
That's why teacher says, please keep it here. Don't mess around. Okay. Time is in hours. How many hours is that?
240 hours.
Okay, so we just keep it at 30 into 8, so many hours. So we have first check your units whether you got it correct. Kilowatt hour. Okay? Abhi cancel karo. Find out what the answer is. How many units is that?
96 kilowatt.
What happened?
For 30 days.
Do this calculation and tell me how much it is. Wait. You don't ask him. I'll correct him. You continue.
For 30 days. 96.
Yeah, correct. How much? What is it?
96.
All of you got it as 96? Okay, what is this now? What is 96?
Kilowatt hour.
You got it as kilowatt hour. So that is kilowatt hour and that is your energy. Okay, so that much of energy you have actually consumed. Correct? So many kilowatt hours. But I also told you something. What is it? 1 unit is equal to how much? It is equal to 1 kilowatt hour. That means it is equal to 96 units. Yeah. 96 units. Understood that part? You're welcome. They have given us what? Power is given us what? वही formula we have to be this thing now. If cross multiplied W is equal to T into T आएगा. ये अगर cross multiplied T is equal to W आएगा. Okay. Now I have to find out what is the cost of energy. Okay. What are they given about cost of energy? They are given the rate as 3 rupees per kilowatt hour. Okay, that means 1 kilowatt hour is 3 rupees. How much did we get? 96 kilowatt hour. It's cross multiply, you get your answer. Where will you get stuck here? Common mistakes. Pay attention. Pay attention. Common mistake is here.
यहाँ करेंगे तो बाद में भी कर सकते
No, it's better to do it here because otherwise for units again you will get stuck. That is one. And here, if it is given in hours, okay, sometimes it may be just about, let us say, 15 hours, whatever it is, okay. Make sure that this conversions is in hour. If they are given in minutes or whatever it is, make sure that it is in hour. We want it to come as kilowatt hour. Is that okay? That is the only confusion that you will have in such type of problems. Got it? Okay. Look at the in-text questions. What determines the rate at which energy is delivered by time? Sorry? What about multiplication? See, mathematically it's not challenging. Sums are very, very easy. Okay, it's just simple multiplication and division. What is challenging here is for you to understand the concepts. That is what we are actually just to test. Okay, right. In-text questions. What determines the rate at which the energy is delivered? Rate at which energy is delivered by a current. What is rate? What are we asking?
Sorry.
Power. Okay. So what is it? So basically what determines the rate? It is the power of the device. Okay, how much current it is actually taking. Current is not the same. Your TV is taking different current and your AC will take a different amount of current. No? So what is it? What is actually determined? What is the power of the device? Okay, got it? One minute? Okay, fine. Next one. An electric motor. Come on, all of you will do this. Do this one. Electric motor takes 5A. What is 5A?
Ampere.
Current. That is your current. Okay. From 220V. क्या है वो? Potential difference V. Okay. Determine the power. So we have to find out P for the motor and the energy which is consumed in 2 hours. So there are many things that they are asking. Okay, come on, let's see. All of you write down. Write down. Write down the information which is given to us. The current is given, which is 5 amp and 220 volt. Okay. The moment we know V and I, what can we find out? Yes. We can find out P because we know P is equal to V times I. So we'll find out.
1001.
Do it in your. We are not discussing anything right now. We have to be working. What is it? What are the units? You will convert it into kilowatt hour only if at all you have to find out energy. Okay, now we are finding out only the power, right? Now, and the energy which is consumed into hours. So the hour part of it is also given.
Minutes में convert नहीं करना है ना?
Energy they are asking you to find out. Find out energy. This is the first part to find out power. Second is to find energy also. Okay. For energy, what will we use?
Convert watt into kilowatt.
Use the same formula. What is energy here? So what is it? W is equal to P into T. But your energy itself is? Okay. 1. Now this is P.
1.1.
That divided by 1000. Just keep it as 1000 divided by time.
2 hours.
2 hours. If at all they have given, but have they given anything?
Ma'am, it was 2200.
No. If at all they ask you to convert it into joule, if they are asking you to, yes, if they are asking you to convert it into joule, then you will have to multiply by 3.6 into 10 raised to the power of 6. Okay, that will give you your answer in joule. Multiply this into. They are not asked you. If they are asking you only in kilowatt hour,
Kilowatt में चाहिए.
okay? I think they have asked you. They have not mentioned it. Written in the hour and the energy consumed in 2 hours. Also. You can convert it into. Come on, all of you do it in joule also and tell me what is the answer. ये हो गया? Power is how much? How much if we get it? 1100. That is in what? Divided by 1000.
7.9.
Okay. And time will be 2 hours. That will give you a unit. This will give you kilowatt hour.
Okay.
This is the energy which is in
2.2 kilowatt.
it is in kilowatt hour. Did you understand here? After calculating, you will get your answer as kilowatt hour. Now suppose this is unit. But now if at all you have to find out the energy in joule. Okay. Into
10⁶.
whatever answer you get, multiplied by that will give you.
तू क्या था? 7.9.
So how much did you get? 7.92. 7.92 into 10 raised to power. Sorry. Okay. If you give your answer as 10 raised to power of 6, that will be ideal. Okay, otherwise you will do a bigger number. Okay. Are we done? Okay, done. Everyone finished? Go back to the last page of your lesson there. Question 18. Question number 18 is explained. We can do that. Why is tungsten used? What are the 2 points that we must remember? Tungsten high point. Okay, it can resist very high temperatures, right? Obviously.
High resistance and high conductance.
Next, why are the conductors of heating devices such as bread toasters, etc., made up of an alloy rather than pure metal?
Because of pure metal, the goods are bad.
Yeah, good conductors you cannot use because it allows the current to pass through. So you should have alloys will have a greater resistance. Alloys will have a greater resistance, and that is what provides a heating element. Got it or no? Okay. Next, because these are the questions I'll expect you to write for homework. Question number 18 is for homework, and I'm discussing the answers. Those are the points that you must write. Mama, you remember to do your homework or no? Why series arrangement not used for domestic circuit? Series and parallel. You were absent. Yeah, in series we have got this voice. Voice when I'm talking, I don't expect you to talk. Right? In series arrangement, we have the same amount of current which is passing through different appliances. Okay? If one of the appliances is not working, the other appliance also will not work. So in your domestic supply, it has to be always done in parallel. Follow? That is the answer that you are going to give. Then, how does the resistance of a wire vary with its cross-section area? Yeah, R is equal to R directly proportional to. Now they are asking only about cross-sectional area. So if the cross-sectional area is big, then the current resistance is less. If the cross-sectional area is small, then obviously the resistance is. Do you understand? So explain it with the help of this formula. R is equal to rho L upon A. So we need to concentrate. You can write down as resistance is inversely proportional to area. I don't see anybody taking down any notes. Will you remember all these things? Will you remember all them? I'm telling you a story or what?
What is the meaning of that, sir?
Arey, we have completed the entire thing. RHO, resistivity. Rho, resistivity. What will you say? Area inversely proportional to resistance. Greater the area, lesser will be the resistance. That is for your question number D. There. Question E.
And L is left, right? So,
They are talking only about resistance and area. So we concentrate only about those. Last one. Wire, copper and aluminium wires usually employed for electricity. Good conductors. Good conductors, less resistance. Yeah. So those two words have to be there in your answer. What will you write? Good conductors and low resistance. Therefore, it is used for transmission. Okay. Come to 17. The three of you are getting thoroughly distracted. Now it's time for me to open the door and throw you out. You can't behave yourself. Come to 17. Sum number 17. Because they're all mixed up now. I think some sums are for power, some of them are for something else. Okay. An electric heater of resistance 8. What is that sign? Oh. Right? 15 amp is what? Current. And time given? 2 hours. Calculate the rate at which the heat is developed in a heater. So let's see here. What is the information which is given? Okay. Now let's see the information which is given. Resistance I time is given, right? And they have to find out what is the rate of heat. Rate is what? Power. Okay. So we have got R, we have got I. Can we use any of this?
I should have
We can use that. R is given, I is given. First find out power. And then you can find out the rate of heat which is there. Is that okay? What is for homework? Okay, 1780. Next class we will conclude this lesson and we'll pick up the next lesson. Which one? Magnetic effects. Human eye, has it started in any school? Yeah, it has started. How much did you
See the speed of light in medium.
Oh my God, can you student भाई? Seriously नहीं मिल रही? तुम लोग चाहे एग्जाम कब है रायन? है ना? वो ऐसे ढूंढ रही उधर ही थी जाके रायन के एग्जाम कब है? या फिर जून आज का रायन के एग्जाम जुलाई 20 और 3 कैंप उल्टा 26 से 28 और मैं जा भी रही हूँ। मैं तो मुश्किल है आज को बता दूंगी। वानी इधर है वानी इधर बॉटल I know right वो crumbs नहीं actually नीचे वो mat का जो black color का रहता है ना काफी का coating it got ruined so I'm gonna throw this back after a month yes sir क्या हो गया पूरी हो गई अरे मैं तो फोटोज में कॉल कर रही हूँ तो प्रिंट आउट प्रोजेक्ट में काफी जर्नल से होता है प्रोजेक्ट वही है ना बस हमें सब में जर्नल से मिशन की रेटिंग है HTML सर्टिफिकेट चिपकाना पड़ता है कंपलसरी होता है वो प्रिंट आउट लेकर चिपकाना पड़ता है लोग तब दिया ही नहीं तो मानने का टीचर तक वो ना दे दसरा का कमर्शियल को ये होगा बाकी तो 50 स्टूडेंट हाँ कमर्शियल में like 200 तक है ये 170 पेजेस का है अपन गेस करो
एक में तो चार में डिवाइडेड है, तो पहले वाले में हमको बैंक जाना है, दूसरे वाले में बैंक जाकर उनका इंटरव्यू लेना है, फिर वो सब चिपकाना है, उनका साइन और वो सब मार्क तो जरा 50 मार्क का कुछ
मैं 40 पेज करने में हाल खराब कर दी, वो करने का जॉब।
अच्छा कोई और लगे कोई और नहीं तुम पी हाँ भी होता है क्या मतलब पी कंप्यूटर राइट
अबे होता है वो
आर्किटेक्ट
ये क्या देखती हाँ उनको ऐसा दिया है
कमर्शियल हो सकती है नहीं है बस मैं तो एक लाख कर जाती 40 नहीं मैंने नहीं किया टाइम का है रिफ्रैक्शन होता है
हमारा यूनिट 1 स्पेक्ट्रम यूनिट साउंड
हमारे सेकंड चैप्टर में चल रहा है लास्ट
हम
में
लोग का पहले
भाई मैथ्स
ऑलमोस्ट पूरा हो गया मुझे पता भी नहीं मैं रुकी हुई हूँ पीछे में वो है अरे मैं वो अलग अलग रखते थे इधर बैठे इधर या मुझे खाने आने वाले
like 5.5 actually oh my god model they model करना है बस सेम है हाँ तो फिजिक्स से रोड
रुके नहीं ना नीचे
क्या ही को
अब ऐसा
नहीं वो नहीं इसमें कौन नीचे लगा उसका छोड़ेगा
अभी आ रही है अरे वो एकदम से जल्दी अच्छा तो इधर आ जाएगी
नहीं
अरे मैंने रुकी थी पर ठीक वो को बदले
प्लान अच्छा फिर भी जल्दी कर रही है ना लोगों को होता है मैं गई थी हिंदी में कितना है क्यों रेंज होता
अभी ना
यार समझा मेरे को मुझे बस हिंदी हाँ अरे मैं ही नहीं ना डेढ़ वाला कोई मैं डालती नहीं ये दुपट्टे पागल मार में
अरे मेरे को 10 मिनट आया था ऐसा सोना अभी देखो ना वो
वालों की कितना चल रही है
ये
हॉकी चांदू को कल पता हॉकी खेलती है एक हफ्ते की डाइजेस्ट खा
वही बोल रही है
हॉकी लाइक मैच हमारे हॉकी का Never. 90. देखो क्या पता था क्या ये बता दो 20 देख ले देखो पता
कहाँ चला गया था भाई? Sit down, and follow please.
एक साइड का भी फर्क होता है यार ना अरे अगर सब ऐसे बैठा नहीं
Where will be the last time?
What is wrong with you,
वो भी बात
Somebody tell me where did we stop in class? Silence. Shout. क्या किया तुमने लास्ट एपरेंट रियल एंड एपरेंट टेस्ट Okay. Did we derive the relation between critical angle and refractive index? Okay. Yes. Okay, let's do that. So we are doing part D, right? Critical angle. So we will have to start with that. I think I already introduced it to you. So what is critical angle? Anybody remembers? It is angle of incidence in the denser medium. Yes. For which? That's what. So it's a. This is what is critical angle. Did you see the video lectures? Did you get time to see the video lectures? So go through it, because today you just try to put up. Because we have covered a lot of basics. So everybody pay attention now. This is a denser medium. This is a rarer medium. So critical angle is the angle in the denser medium. Either you write it as IC or capital C. For which angle in the rarer medium is 90 degree. Okay, this is what is critical angle. Okay? So you can write this. Have you written this statement? Did I give you the statement for critical angle? Okay. So now we'll derive relation between critical angle and Relation between critical angle and refractive index of medium. So when you apply Snell's law in the direction of incident ray, what do you get? Above. So when you apply Snell's law, what relation will you get? Refractive index of, how will we write? 1, 2 or 2, 1? So this is air and this is glass, let us say. These are the two mediums, M and A. A is air. So how will you write it? AM or MA? AM. Correct. Second medium with respect to first medium. This is the first medium now. M. Okay. This is equal to what it will be? Sine of IC divided by sine 90. So this can be written as, what can it be written as? Mu A or 1 upon, this can be written as 1 upon mu MA. This is equal to sine IC or mu M is equal to 1 upon sine IC. So this is the relation between the refractive index of the medium and critical angle. Okay, what's the relation? Refractive index is inversely proportional to sine of critical angle. Yeah, so it's an inverse relation. So whenever the critical angle increases, the refractive index of the medium will be less. Okay, so there you go. So you have a table of critical angle in your book. Look at the values of refractive index and critical angle. You can see the table in your book. So you can see when the refractive index increases, the critical angle reduces. So it is least for diamond and critical angle for diamond is maximum. Right? So there is inverse relation here. Are you getting what I'm saying? So do some nodding or give me some acknowledgement. Okay. Have you understood? What is the relation between refractive index and critical angle? It's an inverse relation. So if refractive index increases, this has to decrease and vice versa. Alright. So what is the critical angle for glass? 42 degree. And what happens if any ray is incident beyond critical angle? Total internal reflection. Okay, so keep this in mind because we are going to have a lot of application for this. So next is, what are the factors that affect critical angle? So one is of course refractive index, right? Factors that affect critical angle. First is, it says the color of light. So color means wavelength. How will it depend? How the critical angle will depend on the wavelength?
Depending on the color of the wavelength, the refractive index.
Yes. So you recall what is the relation of wavelength with refractive? It is inverse, right? So inverse and then inverse again. So it becomes direct relation, right? So critical angle is directly proportional to wavelength. Got it? Because wavelength is inversely proportional to Ri, and this is also inverse. So inverse becomes direct. Okay, this is how the relation is. Second, temperature. What is the relation with temperature? So what happens when temperature rises to the refractive index of the medium? What happens to refractive index of the medium with temperature rise? When the temperature increases, refractive index decreases, right? So again, temperature is inversely related to refractive index. So IC is again directly proportional to temperature. क्योंकि refractive index अगर decrease होगा, देखो, you figure out what happens with rise in wavelength. Refractive index will decrease. Red color कम bend होता है ना? तो refractive index wavelength से क्या है? Inversely proportional. So IC also is inversely proportional. Therefore, this will be directly proportional to wavelength. Got it? Understood or no? Okay. ऐसे समझो इसको. This is this. So therefore, this is directly proportional to wavelength. Both are inverse relation. ठीक है?
So how does the
Yes. How does what?
how does the refractive index decrease? Like, how is it inversely proportional to temperature?
Yeah, when temperature rises, the medium density decreases due to expansion. Therefore, the speed of light would increase. Now you got it. So think in terms of refractive index. दोनों relation मिल जाए. Got it? Yeah. So in both cases, with wavelength and with temperature, the critical angle is directly proportional to both of them. Understood? Huh? How will you write it in English? Critical angle increases with wavelength. Okay. कैसे लिखोगे? Critical angle increases with wavelength of light. I give this relation because this is easy to understand mathematically, but you don't write this in the answer. This is only for your memory. This is what you write in the answer, right? यहाँ पे क्या लिखोगे? Critical angle increases with rising temperature. In all these factors, the common thing is refractive index. जो भी factor discuss कर रहे हैं उसका refractive index के साथ relation याद करो. Then establish the relation with the other physical quantity. Clear? All right. Now total internal reflection. Did I give you the essential conditions for TIR? I have only explained TIR. ठीक है, ये note कर लो. Now we'll discuss TIR. Conditions for total internal reflection. What is TIR? Those who were not present, it stands for total internal reflection. Conditions for TIR. Okay, so now, so first condition, what is the first condition? The ray should travel from denser to rarer medium. Light ray must travel from light ray must travel from denser to rarer medium. Second. What is second?
Angle of incidence greater than the critical.
Yes. I should be greater than critical. Okay? So what is it? Angle of incidence. In denser medium. Angle of incidence. Angle of incidence. In denser medium must be these are the two conditions which must be satisfied. So this can be drawn in the diagram also. So imagine this is glass. You have a source of light like this. Light source. Okay. So let's draw various angle of incidences. So if the angle of incidence is 0, light will travel straight. This is a straight line. Right? Now let us say one ray is incident here. So this is angle of incidence I1. Obviously it will be refracted. So angle of refraction is greater than angle of incidence because ray is traveling from denser to rarer medium. Right? Let us say it is incident. Where else? So now the angle of incidence is increased. So the angle of refraction also will increase. Right? So you have I2, this R2. Everywhere R is greater than I. Whenever the ray is entering into rarer medium. Now there will be a situation, there will be an angle of incidence for which the angle of refraction will become 90 degrees. So this becomes 90 degrees. So this angle is I3 and this is R3. This becomes 90 degrees. So the angle of refraction बढ़ते जा रहा है. There will be some angle for which this becomes 90 degrees. Then we call this angle I3 as critical angle. We call this as IC. Okay. This angle of incidence is called critical angle. Now what happens if the angle is increased further? So you see the angle of incidence is going on increasing. This time this R should be greater than this. So अभी क्या हो जाएगा वो? It is bounced back in the same way. So now it will suffer total internal reflection. Okay. So this point is called TIR. Understood? So the moment the angle of incidence exceeds the critical angle in the denser medium, it will suffer total internal reflection because it is satisfying both the conditions now. Clear? The light ray is traveling from denser medium to rarer medium and I is greater than IC. So here I is greater than IC. Clear? Yes or no? So this is all about total internal reflection. are going to discuss various use cases of total internal reflection in reflecting prism. Use of okay. So there are various applications of total internal reflection. So we have an option now. We don't need the mirror, right? How do we obtain reflection? For that we require mirror. Now we can obtain reflection using this situation also. Wherever the ray is traveling from denser to rarer medium, that can also be used for reflection or forming images, right? Reflection means we can see ourselves in the mirror. तो यहाँ पे भी हम देख सकते हैं, देखो कैसे. First is 45 degree, 90 degree and 45 degree prism. So do you have any questions here? This part is understood and written? Okay. So let me explain this now. So this is the right angled prism. So what it has is these two angles are 45 degrees. Right? So now let us say we call it ABC. Ray is incident along base AB, along the normal. What happens to it then? It will travel straight, right? So as the ray is incident along the normal, it will proceed without deviation inside the prism. What happens on face AC now? Huh? Why? Why? Is greater than the critical angle. What is the critical angle for glass? 42. And what is this angle of incidence? Huh? What is the angle of incidence? Huh? Where is angle of incidence? What is the angle? There are angle of incidence on two faces, AB and AC, right? What is the angle of incidence on face AB? 90. How many say 90? Wow. And what about the rest? You're with 90. Huh? You said 90? 90 with convection, how many? What's your answer? What is the angle of incidence on face AB? Hmm. 90 you said very loud, 0 you are saying. What's the angle? 0. Everybody okay with 0? Why 0? See, this is the angle of incidence when it is oblique, right? Only when it is oblique, right? When it is along the normal, angle of incidence is with the normal, right? So when the ray is along the normal, you could have seen here, no? Angle of incidence only comes when the light is obliquely incident. And it is angle with the normal, not with the surface. ठीक है? अगर तुम्हारा अभी तक यही फंडा क्लियर नहीं हुआ है, and we are almost about to end the chapter now. Keep this in mind. This is a very common mistake. Whenever ray is along the normal, so what is the angle of incidence here at this point? 0. Everybody agrees. What is the angle of incidence here? 45. This 45? Huh?
Yes, sir.
This 45?
Yeah,
Yeah, it's far.
how did you take that time? That is nice.
What is angle of incidence? With the normal or with the surface? What is that 45? So where is the normal? Not drawn yet, right? This is the normal. Normal is an imaginary ray, it's not a real ray. That you have to draw. Okay? So what is the angle of incidence now? So normal always makes 90 with the surface. So if this is 45, this also must be 45. Understood? Once I am drawing it, next you have to understand. Okay? By geometry. So now when the angle of incidence is 45, where is it, in the denser medium or rarer medium? Denser. So this ray is traveling in the denser medium and making an angle 45. Is it greater than critical angle for glass? Yes. Because what is critical angle for glass? 42. It's given in the table. Okay? Check where it is given in your book. So critical angle of glass you have to remember. It's 42.
Only glass or other.
And diamond, which is 25 or 24, I think. 25. So glass and diamond you remember. So then what should happen to this ray now? It's greater than the critical angle. What should happen? Internal reflection. So by law of reflection, it should be, angle of reflection also should be 45 degrees, right? It should be 45. Yeah? So this is also 45. Understood? So when this is 45 and this is 45 degree prism, this is 45 and this must be 90. That means the reflected ray becomes perpendicular to base of the prism. Base name, this base. Right now this is the base. So what should happen to this ray now? Comes out straight, right? Okay, so this is what happens. So what is the angle of deviation in this case? 90. How? What is the angle of deviation? How do we define angle of deviation? Deviation क्या होता है? हमने lateral shift cover किया ना? Deviation बताया था? Angle between incident and emergent, है ना? So incident का direction क्या है? Emergent का direction ये है. What is the angle of deviation? Full angle, 90 degree. ठीक है? So use of TIR in reflecting prism, which is 45-90. Right angle prism में क्या होता है? Deviation by 90 degree. So what is the conclusion here? This is how we achieve deviation by 90 degree. ठीक है? Where do we use it? We use it in periscope. This reflection is used in periscope. Used in periscope. This is the application. How can we use in periscope? Everybody knows you have made maybe the project on periscope, right? So if a ray travels like this, you have another mirror. Using mirrors, you must have made it, right? Have you made a periscope? Have you studied about it? Have you studied about periscope? In submarines it is used, right? So what did we use in the lower classes? To make periscope, we incline two mirrors at 45 degrees, right? And put it in a pipe. We made opening here with some other pipe, right? So this is how the periscope was made. Okay, so when it is housed in a pipe, you can make a periscope like this. But the problem with mirror is, mirror does not reflect the light 100%. Okay, mirror will not reflect the light 100%. Some of the light will be absorbed, right? But this is total internal reflection. So here, whatever energy, light energy is coming from the object, it is totally reflected. So the image formation in case of reflecting prism will be much clearer, much brighter as compared to image formed by mirror. Okay, so this has the advantage in terms of forming a better quality image, since it obeys 100% reflection. Is that clear? So how can we make periscope using this prism? We can actually use another prism like this. So it will come here and get reflected. Understood? This is how. Using two prisms, we can make a periscope. So how to make the periscope ray diagram and all, that's not required. It's just mentioned in the book that deviation by 90 degrees is used for making periscope. So this is the first case. Right? So only one prism and only till here you draw. This is only for the understanding. So this was first use of 45, 90, 45 degree prism. Second use is deviation by 180 degree. We will now use this prism to obtain deviation of 180 degree. So in this case, the prism is kept like this. So we have ABC. So now when the ray comes here, this is 45. This is what is happening. Okay, so what is the deviation now in this case? Oh, I made a mistake here. It's not deviation by 180. It's the third case in the book. It is used to erect this kind of application is just to erect the image. See, let's say we have an object kept like this. This is AB. So this A becomes A is here. Okay. When the object is placed like this, BA, the image is inverted. Okay. So this is the third application. Erecting prism. It is called erecting prism. So Is there any deviation? Is there any deviation in this? No deviation. It just flips the image. So what is happening here? TIR. What is happening here? TIR is happening at the bottom. What is happening here? Refraction. Okay. So refraction taking place at face AB and BC. TIR taking place at face AC. So this was the third example. The second example in the book is deviation by 180 degree. So where are we going to use this prism? Second case in the slide projection. Used in slide projection. Everybody understands what is a projector? So you just keep a slide, its image will be reversed. So you keep the slide itself reversed, the image will be made upright. So how do we obtain 180 degree ka deviation? For that also we'll keep the prism like this. So there are three applications for 90 degree, 45 degree, 90 degree prism. For this, go straight, then there will be one TIR over here. Why TIR is happening is because of these two conditions being satisfied at that point. Okay, so that's why TIR is happening. So you have to just mention where is TIR. Okay, so this is ABC. Then take another ray. Okay, so where is TIR taking place? Here. Where QB should be follow the ray. This becomes B. So is the angle of deviation 180 degree? So what is the incident direction? This. What is the emergent direction? So incident and emergent direction में क्या angle? 180. ठीक है? Incident ऐसे, emergent ऐसे. So the angle of deviation between these two rays is 180. Correct? Right now, one ray is going like this, and the other ray is coming like this. So when you bring them together, what's the angle? 180. Okay. So where do we use it? We use it in making binoculars. Used in binoculars. Can anybody guess how do we use this in binoculars? How do you use it in binoculars? So binoculars have two tubes, right? So the remote object, if any light ray comes from the remote object, this is how it can go. ठीक है ना? You have to make a pair of prisms, and this is how you can capture light, right? So the remote object is here, so the ray comes and then it reaches eye. It will also have mirror, it will also have lenses. So I am just showing you the use of prism. Everything, yes. So it's a complicated instrument, it's not simple. Just this spec is so complicated. How much process you go through to make this? This is a binocular. Right? So, this could be, I don't know exactly how they are placed, but this is how you can see, like, there would be a pair or infinite rays coming from the object side, and this is how it enters the application part. I am just just describing it on the board, but you're not supposed to draw the ray diagram for that. This is just only for you to understand. This diagram, only for your understanding. Okay. But you have to know where it is used because the application is asked. So are we good till here? Okay. Now we will move on to use of TIR in the second type of prism, which is isosceles prism. Okay. So by now you have understood that why do we need a prism? We produce different angle of deviations. Okay. Because it finds various applications in optical instruments. Now we will not be giving you what is the application. Now we will only be giving you the deviation angle and how it is produced. Okay. So next. So the first application is for second. The isosceles prism. What is isosceles? Is this the spelling? Isosceles reflecting. What's the application? Deviation by 60 degrees. We now want to obtain deviation by 60 degree, for which we will be using isosceles reflecting prism. What is the isosceles? Isosceles reflecting prism. Not isosceles, it is equilateral. One second, some mistake. Equilateral. Okay, isosceles नहीं, isosceles में तो दो ही side equal होता है. It is an equilateral prism. So what is an equilateral prism? Huh? What is an equilateral prism? All sides equal and yes, same property as equilateral triangle. Is it looking like an equilateral prism? Okay. So everybody, what you have to keep in mind is the sequence, how the ray is flowing. Like here, the prism are kept in the same way, but the way the ray is inputted it inside the prism, that is different. Okay. So here it is entering from the base here on one of the side surfaces. So here, this is 60 degree. See, all the angle of incidences are normal except for this. Everywhere else in the reflecting prism, the ray is traveling normal to the face of prism. Okay? Only that is an exception. When you erecting prism case में, that is the only exception. Okay? Now look here. When the ray is inputted from here, then what do you get? What is this angle? 90. That means it will go straight. So what is this angle now? What should be this angle? 30. So is this angle of incidence? Is 30 angle of incidence? So what is the angle of incidence? For that you have to draw a normal, right? So what is the angle of incidence? 60. Okay, na? Because 30 plus 60 will be 90. 60 degree. So what will happen here?
Sir, in the book, the incident is traveling from side A.
उधर से आ रहा है क्या? ठीक है, वो उससे भी कर सकते हैं. It's all right. दोनों तरफ से हो जाएगा. ठीक है, चलो यहाँ से करना है. एक बार करके देखते हैं क्या होगा. ठीक है. So let us see. So if what will happen here? TIR or? So what I will do is I'll just reverse the direction. Okay. I'll just reverse the direction. ये जो direction. क्या होगा देखो. TIR से क्या होना चाहिए? It should be 30. Correct? क्योंकि ये क्या हो गया? ये भी 60 है. ठीक है ना? ये 60 है, अगर यहाँ पे TIR हो रहा है, then this also should be 60. So the other should be 30. तो ये क्या होगा? सीधा निकल जाए. Isn't it? So what is the angle of deviation? So angle of deviation is angle between this and if you extend this ray forward. So what is the angle between these two? This is also 30, right? Okay. So 30 plus 30, it is 60. In this diagram, if you just reverse the rays, you get your book diagram, isn't it? Just change the direction, you get your book diagram. Understood how we got 60 degree? Sure. Okay. Next is deviation by less than 60 degree. Third, now we are using a third type of a prism. Less than 60 degree using 30, 90 degree at 60 degree. Okay, so there are three types of prism we have used. In the first case we used 45, 90, 45. Okay, second case we used equilateral prism. Now we are going to use right angle prism with this angle. So this is going to be so you have 90, this is 60, and this is 30. Okay. So how do we obtain deviation by less than 60 degree? So let me input a ray from the base. Should be straight. So what happens? So obviously this will suffer TIR. Again, this is 60. This is also 60. Now tell me, what is the angle of incidence here? What will be this angle of incidence? Is this looking 60 or? No, चलो बताओ, what will be angle of incidence here? देखो, if this is 60, this also will be 30. So 30, 30, है ना? If you extend it further, क्या होना चाहिए? This should be 60. So ये कितना होना चाहिए? 120. Linear pair बन गया है ना? 30, 120. तो ये कितना होना चाहिए? 30. Correct? So you have to figure out what is the angle of incidence. This is the angle of incidence, 30 degree. So what should be angle of refraction? Is it greater than critical angle? 30 degree? No. So now here you will have refraction. So refraction angle is taking place in rarer side, right? So this angle would be greater than 30 degree. Okay, so what is the angle of deviation? Angle of deviation will be this angle because this is the original direction which is same as this. This angle must be less than 60 degree because angle of refraction is greater than 30 and total is 90. So this should be 90 minus greater than 30, which is less than 60. Correct? So this angle will be less than 60 degree, which is also the deviation. Isn't it deviation? What is the original direction? This is the direction, which is same as this side of the prism. Parallel. This ray and this is parallel. So this and this angle is same as this and angle between this. Making sense or no? देखो, you extend this ray, क्या हो जाएगा? 30 रहेगा ना इसके साथ. ये दो parallel ray, corresponding angle क्या है? Think about it. How many of you got it? You got it? She's not believing that she got it. Shaky ground a little bit. What's suppose I have two parallel rays, okay? So I have this angle as less than 60 degree. So what will be this angle? Will it not be less than 60 degree? Are they not corresponding angle? This and this is parallel side. So what is this is the original ray and this is the emergent ray. Same angle, no? चल पता deviation है कि नहीं? ये एंगल लेस देन 60 डिविएशन बोल रहा हूँ मैं इसके कंपैरिजन में है ना कि नहीं? क्योंकि ये और ये एक ही बात है. डायरेक्शन देखना आपने, ठीक है? So original direction के respect में this will be less than 60 degree. Clear now? Yes, Aditya. You're a national champion, huh? Swimming. Yeah, you told me. Your friend. What's his name?
Okay, I did complete classes, but
Okay. The thing is, I'm just doing my baby steps in swimming. So, मेरे कुछ tips दे देना कैसे बच्चे कैसे पार वाला दे. I tried twice, but failed. कितना दिन लगता है स्विमिंग सीखने के लिए? एक महीना. Deviation simple है. 1 घंटे में समझ आ जाता है. 1 महीना मतलब मसल मेमोरी बिल्ड करने. 1 दिन में सिखा सकता है कोई स्विमिंग? 1 दिन. नहीं?
Sir, your body has to adapt to such serious exercise.
मतलब does it take lot of effort?
Yes. At one point, you stabilize
it's going faster, yes.
तो मैंने कभी नहीं सीखा पाएगी स्विमिंग.
It's going faster, yes.
Faster नहीं यार मतलब I just try to do this and I sink inside. ठीक है? Okay, coming back to deviation work. There are 3 more cases in this. 3 more cases. So far, all the cases involved somewhere TIR. है ना? So here it is TIR, and here is refraction. Refraction at this point, TIR at this point. 3 more cases for the same prism. Go after the